Okay, next we'll do a slightly different example, but it looks alike, looks similar to our previous example. Okay, now you have a higher tank compared to our previous example. Here the curved part is only at the bottom here, okay, where at this part is a straight tank. Okay, so the question is find the resultant force. Find the resultant force here. Okay, I take the liquid to be water. Okay, and then the height from the curved part to the water surface is 1.85 meter, and the radius of this curved surface is 0.75 meter. Okay, before we get started, compare this example with our previous example. Okay, the difference is previous example we only have this part without the water part up there. Okay, but now in this example we have liquid on top of your curved surface. Okay, how do we draw our free body diagram? Our point of interest is the curved surface. This is the curved surface, so we draw an imaginary horizontal line and also imaginary vertical line, okay, between these 2 points. Okay, and then what do you have? You will have W going downward, the weight of the water. You will have resultant force acting that way, and then F V F H. Okay, and over here on the imaginary vertical surface you will have Fx, and over here you will have Fy. Okay, so F resultant is equal to Fh square plus Fv square. Now we look at the Fh first, horizontal. Okay, Fh equal to Fx. Okay, here Fh equal to Fx. There's no other horizontal force acting on your body there. So what do you have? Again, take this part only. Okay, this vertical plane surface as your point of interest, where your Fx is acting onto the surface. So you will have gamma Hc A. Gamma is 9.81 kilonewton per meter cube, the Hc. Okay, remember definition of Hc? Hc is always the vertical distance, okay, from the liquid surface to the centroid. Okay, now this length is 0.75. Okay, 0.75 divided by 2. Okay, the width of the tank, we take it to be 2 meter long. Okay, so it's actually a rectangle shape from this side. Okay, now coming back to our Hc, is this all? Is this our Hc? It's not complete. Okay, so because it is a vertical distance, it is to the centroid, but it's not measured from the liquid surface. Your liquid surface is 1.85 meter above your imaginary vertical line, so you have to plus 1.85. Okay, next your E always the surface area in contact with the water. Now, your surface of interest, you are talking about which surface? I draw back the diagram. You have 1, 2, and 3. You have 3 surfaces. Okay? But here, when you are looking at the fx, fx is acting on which surface? Is it on 1, 2, or 3? Okay, the answer is quite obvious. It's acting on your surface 2. Okay, so you have to look at the E of this surface. Do not find the E at here. Okay, I'm telling you guys, this is a common mistake done by student, where you guys will use the E here, or sometimes they use the E here. Okay, which is not true. You have to look at where your resultant force is acting, your surface of interest. So you are interested with this part, okay, where your Fx is acting on it. So you look at the area here only. Okay, so what do you have there? You will have 0.75 times with the width. The width is 2. So this will give you 32.74 kilonewton. That is FH. Next, we go to FV. Okay, vertical forces. Now look at the diagram here. You have FV going upward equal to the FY going downward. And then another going downward force is W. So you have to plus W. Okay. So what do you get there? You'll have Fy. Now, look at this plane surface, okay, which is actually here. Okay, this is the imaginary plane surface, horizontal plane surface, which is located at this point in that tank. So do you have any liquid above that surface? Here, that's the liquid, okay? So it's actually, you have the surface in its submerged under the water, where the height is 1.85 meter. So your Fy is equal to gamma Hc A 9.81 kilonewton per meter cube Hc. This is a plane surface, okay? Regardless what is the type of this, what is the shape of this surface, the centroid always be somewhere on this horizontal line. So your Hc is 1.85. Okay, do not divide this into 2. Okay, common mistake done by student is sometimes they will make Hc equal to 1.85 divided by 2. No need for that. Okay, because this is your Hc center somewhere on the plane horizontal surface, which is located 1.85. Okay, next the A. Okay, for the A, area in contact with the water, again same concept. You are interested with this surface at point number 3 here, okay, in which at that point you have your Fy acting. So you don't calculate the surface area down there. You are only interested with this surface, okay? So what do you have? You will have 0.75 times with 2. Okay, this will give you the Fy. Next, we look into the W. Okay, not complete yet the answer. W, if you don't remember again, the W is equal to gamma V. Okay, so what do you have here? You will have 9.81 kilonewton per meter cube. That's the gamma for the water. Times with the volume. Volume of the water inside this Okay, so it's actually 1/4 of the whole cylinder. So you have pi 0.75 square. Okay, this is the A. You want to have a volume, so you have to times with the length or the depth. Okay, the width depends on the perspective where you look at it. So 2. Okay, that will give you the W. With that, so for your FV is equal to, okay, you will get 35.89 kilonewton. That's not the resultant force. Your resultant force is F resultant equal to this one. Okay, so what do you get there? You'll have 48.6 kilonewton. That's the answer. Okay, as a soft reminder, sometimes student in the class, they will forget to find the resultant force once you get the F vertical and also F horizontal. Okay, always come back to the question, find the resultant force. Okay. Okay, next, if let's say I add on to the question, find the location of the resultant force. Okay, this is quite clear. Okay. The location should be defined by the angle. Okay, so your angle is tangent FV over FH. So your resultant force is acting approximately 47.6. Okay, I think that's it for this example.